This is video 532, and the goal of this video is to verify identities and evaluate expressions using the half-angle formula. So today we're going to see the half-angle formula. So again, we're going to evaluate things, so we're going to find different values of angles as well as verify identities. So let's take a look at the first example. So the first example, it starts out similar to what you saw with the double angle formula. When we're working with the half-angle formula, we're going to start again with drawing a picture. Because we noticed that in the half-angle formula we need cosine of alpha, and so in order to do that I need to draw a picture of alpha, or in this case theta, in order to find that cosine of theta. So I'm in quadrant 2 because of the range there between pi over 2 and pi, and I have a 3 over 5. Find that missing side, it's going to be -4 using Pythagorean theorem, and keeping in mind I'm in quadrant 2. So that negative is important here. So now let's take a look at finding the exact value of theta over 2. Sine of theta over 2, excuse me. So I'm going to use the formula. But first, I notice I need cosine of theta. So I need to find that that's -4 over 5. Now I'm simply going to plug it into the formula. But instead of putting cosine of theta in, I'm going to put in -4 over 5. Now, all over 2. Notice that the 2 and everything's inside of that square root. Now I'm going to just start to simplify. Subtracting -4/5 is like adding 4/5. It's still over 2. Now again, I don't like fractions within fractions, so let's make the top just a single fraction by getting like denominators. So I'm going to be 5 over 5 plus 4 over 5, which is just 9 over 5, all over 2, and square rooted. Last but not least, I'm going to take care of the fact that I'm dividing by 2 by changing that to timesing by 1/2, because that's equivalent. So again, that dividing by 2, I timesed by the reciprocal 1/2. Now let's take a look at making this proper. Square root of 9 over 10. Oh, I'm sorry, I forgot one thing, didn't I? I forgot the plus or minus. That's important, and we'll talk about that in just a second. That plus or minus, you see me adding all that on there? That's part of my formula originally, so I need to make sure I add that on to my problem. So I'm going to get plus or minus. I'm going to square root top and bottom because remember we can't have a denominator with the square root. So on the top, square root of 9, that's easy, that's 3. But I get square root of 10 in the bottom still. So I'm going to make that proper by timesing top and bottom by square root of 10. Remember that? Back in September we talked about that. And that's my final answer. However, the final answer does not have plus or minus in it. The final answer has plus or it has minus. You cannot have both those symbols there. It's one or the other. There's only one correct answer to this problem. So now let's talk about this plus or minus and which one is correct for this particular problem. So in this case, remember we're looking for sine of theta over 2. You have to ask yourself, will the sine of theta over 2 be positive or negative? You have to visualize where pi over 2 will be, or theta over 2, excuse me, will be, and ask yourself, will sine be positive or negative? So take a look back at that picture we drew. It's going to come in real handy. That's theta, remember? We drew theta. Think about theta over 2. If we cut that in half, where will it be? It's going to be in quadrant 1, because cutting it in half will leave me in quadrant 1. And in quadrant 1, sine is positive. So sine of theta over 2 will be bigger than 0, and I'm going to have a positive answer. So my correct answer is positive 3 square roots of 10 over 10. So that's potentially the toughest part of the half-angle formula. You have to ask yourself, is it positive or negative? And you have to use the picture to help you answer. So let's take a look at another example. We're going to start with looking at the positive or negative thing, and then we'll talk about the simpler part of working with the fractions and the square roots. So let's draw a picture of theta. Theta is in quadrant 3 because it's between pi and 3 pi over 2. I'm going to add my missing side lengths, 1 and 2, and they're both negative because I'm in quadrant 3. And the hypotenuse is square root of 5. Now I'm looking for the cosine of theta over 2. So again, I'm asking myself, the cosine of theta over 2. I know the formula according to the half-angle formula, but I still want to figure out, is it positive or negative? I have to find that out. Don't leave the answer as plus minus, because that does not make any sense. There's only one correct answer. So I have to ask myself, since theta is greater than 180, pause here. Hold on. Since theta is greater than 180 because of what this says, and I'm using 180 because I think most of us are better with that than pi. Pi is 180, right? And theta is bigger than 180. That means theta over 2, cut it in half, it will be bigger than 90 degrees. Theta will be bigger than 90 degrees. Correct? Now let's take a look at that picture. That picture is an angle that's in quadrant 2 because the angles in quadrant 2 are bigger than 90 degrees. There's 90 degrees. This will be theta over 2. So I will be in quadrant 2. Theta over 2 will be in quadrant 2. And then ask yourself, is cosine positive or negative in quadrant 2? In quadrant 2, cosine is negative because it's negative on the left side of the graph. So therefore, my answer will be negative. So I don't need that plus or minus anymore. I'm just going to put a negative in front because the answer will be negative. Weird, right? So you're going to be wanting to ask lots of questions about this in class and verifying that you answered that part right. Now let's take a look at plugging in the number. So I'm simply going to plug in cosine of theta, which is negative 2 over square root of 5. I'm going to make that proper because I know I don't want that denominator there with square root of 5. Let's plug that into our equation now. I'm going to get 1 minus 2 square root of 5 over 5. Notice I put minus because this is negative, and I'm doing plus negative cosine of theta, so it's going to be minus 2 square roots of 5 over 5. Now let's take a look at simplifying this fraction. Again, we're going to create a common denominator, so we're going to put 5 over 5 for 1, minus 2 square roots of 5 over 5. Put that common denominator together into one fraction, and the next thing I'm going to do is change that 2 to timesing by 1/2. Because dividing by 2 is the same as timesing by 1/2. Timesing that out, I get 5 minus 2 square roots of 5 over 10. So we're getting close. We have a fraction inside of our radical still, which is not proper. So let's clean that up by separating by creating a perfect square in the denominator. So this is a slightly different move than I did in the previous example, but you'll see where I'm headed. I chose 10 because 10 times 10 will make a perfect square, which is square rootable. Making up words now, don't mind me. You can square root 100. So bear with me here. We get 10 on the bottom, which is a perfect 10 squared, which is a perfect square. On the top, I distribute the 10. I get 50 minus 20 square roots of 5. And on the bottom, I get 100, square root of 100. But square root of 100 is just 10. So there's your solution. Oops, don't forget, we need the negative. So the solution is negative square root of 50 minus 20 square roots of 5 all over 10. So that's a proper answer. That's exact for the cosine of theta over 2. So let's take a look at some other good cases. These are some easier ones. You'll probably like some of these because they're going to be kind of working a little bit backwards, okay? So, well, not backwards, but a little bit more exact. We're asking, what is the cosine of 15 degrees? Well, first we always look to our unit circle and we see, uh-oh, I don't see 15 degrees on my unit circle. So I ask myself what formula I might be able to use. So first question I ask myself, theta divided by theta divided by 2, is there a theta that gives me 15? Well, the answer is 30. 30 divided by 2 gives me 15, and 30 is on my unit circle. So I can use the half angle formula where alpha is 30, because cosine of 15 is the same as cosine of 30 divided by 2. So now I'm going to use the cosine half angle formula, and I'm going to use positive because cosine of 15 is in quadrant 1. Cosine is positive in quadrant 1. And I'm going to do square root of 1 plus cosine of 30, because alpha or theta in this is 30. So alpha is 30, all over 2. Now I'll use my unit circle. I'll look on my unit circle and find the cosine of 30 is square root of 3 over 2. And I still have the rest of my fraction. I just copy down. Now let's work on those like denominators and changing things up so it's simplified and proper. So 2 over 2 plus square root of 3 over 2 all over 2. Instead of dividing by 2, I'm going to change it to timesing by 1/2. And I also noticed Gabe created one fraction out of these two things being added that have the same denominator. And then I times by 2. Instead of dividing by 2, I times by 1/2. Which gives me 2 plus square root of 3 all over 4. Now I'm going to separate and make it proper. The square root of 2 plus square root of 3 all over the square root of 4. But thankfully square root of 4 is a perfect square and I just get 2. And I'm done. My answer is proper and simplified. So that's the correct exact answer for cosine of 15 degrees. It's positive because it's in quadrant 1, and I worked it out using 30 degrees because I knew the answer for 30 degrees. Let's take a look at, we're skipping the tangent of 3 pi over 8 just for sake of time. I don't want to waste your time watching even more examples. We'll do that when we get to class tomorrow. So here's your multiple choice question and your free response question. So do your best to kind of follow what you saw in the video and evaluate these expressions and find the exact values. So bring those questions into class, and thanks for watching.